Right, in this video I want to give the proof of the quadratic formula, which was this is the quadratic formula, and in this video I want to prove it, and the way we'll prove it is we'll complete the square on this equation here. X squared plus bx plus c is equal to 0, and you can have a go at doing that if you like, and hopefully you'll end up with this. So you can have a go now if you like, and I'm gonna do it and you'll see if you've done it right or not. Right, so first step when we complete the square on this is I'm going to divide everything by a. So I've divided everything by a. And the next thing I'm going to do is I'm going to divide this here by 2, because that's what you're supposed to do. You divide it by 2, then square it. And then when you've divided that by dividing by 2, you get b over 2a, and then when you square all that, it just means you square the top and square the bottom, so you get b squared over 4a squared. And now what we'll do is we can complete the square, because we've got this term that we need here. So if you remember, what we'll do is we'll halve that. So I put b over 2 in here and square it, so that's what I'm going to have on that side. And then if I have that on one side, I must have it on the other. So I'm going to put b squared over 4a squared on the other side. And I have got that on here because when you square this term in here, you've seen that you do get that. And the other term is I want to move this one over, so I'm going to move over c over a, which will become minus when I move this over. Next thing that I want to do is I want to combine the fractions here. And then when you combine the fractions, this is what you get, because it's similar for when you do fractions in school. And the next thing I want to do is, because I've got a square here, I'm going to square root both sides, and I'm going to get this is always a b, by the way. That's a b there, that's a b, it's always been b's. I've got no numbers in here at all apart from the 4 and the 2 in the little square here. And then when I square root this fraction here, what I do is I take the square root of the top and the square root of the bottom. And then when I do that, I can't simplify this bit here, but on the bottom I get 2a. And then, oh, and of course you have to put the plus or minus in here. I nearly forgot about that. That's an important thing, because we've got a positive and a negative root here. And the next thing I want to do is because I've got this b over 2a on this side, I want to get x equals, so I'm going to move this b over 2a over to the other side, and I'll have to come along here a bit, and then I'm going to get x equals, this becomes a minus, so I can put minus b up here, and then the plus or minus is still there, and my square root of b squared minus 4ac over 2a. Now notice, because this fraction's become negative here, I can put the negative sign in the numerator, because if I put the negative in the numerator and the denominator, of course they cancel, so that's still a plus, and you know that when you change sides of something it changes sign as well. And that was the proof. I started off with this expression here. I've done all this work on it, completed the square, and I've ended up with this here, which is the same as the quadratic formula that we had at the top. So there's your proof for the quadratic formula. That's where the formula came from, and that's why it was invented, and that's, now you know why all these different things come up in it, and why the formula's like that and not another sort of arrangement, because it looks quite strange at first, you see.